In this tutorial, you'll build a make scenario that batch generates dlex reports from files in a Google Drive folder, saves each resulting PDF, and then rasterizes those PDFs into TIFF images. Both the PDF reports and their corresponding TIFF outputs are written back to Google Drive. This tutorial demonstrates a practical, real-world workflow that shows how easily the DynamicPDF API can automate document generation and downstream processing. The first make action we use is the Create Report, dlex-layout, dlexpath action. This action creates a PDF by sending a dlex template path and mapped layout data JSON to the dlex-layout endpoint. The second action we use is the Rasterize PDF Image action. This action rasterizes a PDF and returns images encoded as base64 text as a JSON document. Before we start building our scenario, let's go to the DynamicPDF File Manager and set up the sample used in this tutorial. Select Files, and then the Samples folder. Then click Add Samples. Select Create a PDF endpoint, and then click Add to add the sample. Go to the newly created folder. Now, download the Simple Report with Cover Page JSON file. Right-click and select Download to download the file. Double-click the Simple Report with Cover Page dlex file to open it in DynamicPDF Designer. In this dlex template, you create a simple report with a cover page. The produced PDF is a 3-page report with a cover page. You can learn how to build this report at the Create a Report with Cover page in Designer Solutions. Go to the toolbar and open the JSON data used to generate the report. Now click the little green arrow to generate a PDF preview of the report. As you can see, it generated a 4-page PDF document, a cover page, and then 3 pages of line items. Now go to Make and create a new scenario. Click Create Scenario and then rename the scenario. I name it dlex-report-and-rasterize-tutorial. Add a new Google Drive app to your scenario. Then select Watch Files in a folder. Select the Google Drive folder for the scenario to watch for new files. Click Save to save the module's configuration. Choose All as the scenario's starting point. Go to Google Drive and add the file that was downloaded earlier. Recall that this file is the JSON data used to supply the needed data to the dlex template. Return to Make and add a new module. Select Google Drive and then download a file. Map the File ID field to the file ID in Step 1. This ensures that after a file is picked up in Step 1, it is then downloaded in Step 2. Click Run once, and let's test the first 2 modules of our scenario. And from the output, you see the file was downloaded. Now let's add another module to the scenario. Select the DynamicPDF API app to add it to the scenario. Select Create Report, dlex-layout, dlexpath as the app's module action. There are 3 fields we must provide values for: DynamicPDF API key, dlexpath, and file. Notice the file field already mapped the file to the file from Step 2. Go to your DynamicPDF API dashboard and select the clipboard icon to copy the key to your clipboard. Paste the key, and now let's get the path to the dlex template. Go to the File Manager, then Creating PDF endpoint, and then right-click on the Simple Report with Cover Page dlex file. Select Copy File Path to copy the relative path. Let's test the scenario. Right-click on Step 1 and select Choose Where to Start. Select All. This ensures the file is processed. Click Run once. The scenario ran without error, so let's review the results from creating the report. As you can see, the generated report was returned as binary data. Now we wish to both save the generated report to Google Drive, but also to take the created report and rasterize its pages into images. To do this, we use a router. But first, notice that Step 3 did not provide a file name for the PDF. We need a file name, so before adding a router, let's add a Tools Set Variable module. Enter Output PDF File as the file name. Then select Name from Step 2. Now let's modify the name by adding -output to the file name and also replacing the JSON extension with a PDF extension. Use a replace function, but first be certain the file is all lowercase and replace .json with -output.pdf. Let's test the scenario. So go to Step 1 and reset the module, and then click Run Once to run the scenario. Let's look at the results of running the Tools Set Variable module. And we see from the output, it returned the PDF file name properly constructed. Now let's add the router. Add a flow control to the scenario. Select Router to add a router. And it provides two parallel branches the scenario's processing can now take. You can add more branches, but we only need two. Add a Google Drive Upload a File module to branch 1. Change the Enter a Folder ID field to Select from the list. Then, select the folder location to upload the file. Now change File to Map and map the outputted file name from Step 4. Change the data field to map to the generated PDF output in Step 3. Now for the other path. Add a DynamicPDF API Rasterize PDF module. Get the API key from the dashboard. Change the file to map. Then map the PDF file name field's value to the outputted PDF file variable in Step 4. Map the PDF file data field to the generated PDF output from Step 3. Change the image format to TIFF. Do not modify any of the other values. Reset Module 1 and run the scenario. As it runs, notice that it runs both branches of the scenario. Now let's review the output from Step 6 and ensure it uploaded the PDF report to Google Drive. That is not the correct name for the PDF report. We must have did something incorrectly when mapping our outputs. Let's look at the Google Drive Upload a File module in Step 6 and see if it's to blame. Oh, there's the error. We mapped the file name incorrectly. Map the file name to the output PDF file in Step 4. Reset Module 1 and run the scenario again. After it finishes executing, go to Google Drive and ensure the file is now uploaded with the proper file name. Now we need to process the rasterized images. Recall that the Rasterize PDF module returns the images as base64 encoded strings in a JSON document. But we want to save the rasterized images to our Google Drive. To do this, what we need to do is parse the returned JSON, extract the files, convert them to binary, and then upload them to Google Drive. Let's first parse the JSON returned by Step 7 into a new data structure containing only the image files. Add a new Parse JSON module. For the data structure, select the PDF image structure returned in Step 7. Map the PDF image results array from Step 7 to the JSON string field. Run the scenario, and let's review the output from Step 6. Ignore the warning, as we are only testing the scenario. Now let's review the output from Step 8. As you can see, it transformed the JSON input into only the needed base64 encoded images and each image's associated metadata. We still cannot iterate through the image data, though. To do that, we need to add an iterator. Add a Flow Control Iterator module. Map the images array from the step we just added as the array. Now we want to properly format each image's name to save in Google Drive. We also want to convert the base64 encoded image to binary. To do this, add a Tools Set Multiple Variables module. Click Add Item to add our first variable. Name the variable name as binary data. Then map the data from Step 9 to the variable value field. Now let's convert the data to binary using the toBinary function, where we specify the input as base64 encoded data. Now that we have it converting the images to binary, let's add the image file name. Click Add Item to add a new variable. Name the variable as FileName. For the variable value, map the output PDF file from Step 4. Add a dash, then map the page number from Step 9, and then add the TIFF extension. Now add a Google Drive Upload a File module to the scenario. Select Map for the file and map the file name to the file name from the previous step. Then map the binary data to the data field. Now let's run the scenario. Reset Step 1, then run the scenario. go to the report output folder, and we see it generated the report. Oh, ignore that there are 2 copies. We forgot to delete the previously created copy. Now go to the image output folder, and we see the 4 rasterized images, correctly named as TIFFs. This tutorial demonstrated how to build an automation workflow in Make using the DynamicPDF API Make app. By combining Google Drive modules with DynamicPDF API modules, the scenario automatically detects layout data files. It then generates PDF reports from dlex templates and converts the resulting PDFs into rasterized images. The workflow then saves both the generated PDF document and the corresponding images back to Google Drive. The tutorial illustrates how document generation and post-processing can be orchestrated entirely within the Make visual automation platform. Files can be retrieved from external sources and passed into the DynamicPDF API endpoints. They are processed and then routed through additional steps such as JSON parsing, iteration, and file storage. This approach enables scalable document workflows to automatically generate reports, convert them into images, and distribute the results to downstream systems. As the tutorial shows, organizations can integrate DynamicPDF API capabilities into broader automation pipelines. I'm James, developer evangelist for DynamicPDF, reminding you, when you think PDF, think DynamicPDF. See you next time.